Let's start with what a worker pool actually is and why it exists. When the platform processes messages or requests, it doesn't handle them one by one in a single line. Instead, it has a whole team of internal workers that pick up tasks in parallel. That team of workers is what's called a worker pool. Think of it like a call center. Instead of one operator answering calls one at a time, several operators work simultaneously, so calls don't pile up waiting. The worker pool stats page lets you see how well that team is keeping up with the workload right now. It allows you to check whether a backlog of unprocessed tasks is building up, see how many tasks and timers have passed through the system in total since it started, and spot whether any single worker is more overloaded than the others. This is the primary tool for noticing that processing is falling behind before it becomes visible to end users. Now for the page's settings themselves. The worker pool field lets you choose which pool to view. On a single server, there is usually only one pool, and if that server runs more than one pool internally, they would all appear here. It's worth noting that this list only ever shows pools running on the server you're currently connected to. There's no way to view another server's worker pool from this page. To check a different server, you'd need to open its own worker pool stats page directly. The refresh period IS field controls how often the page updates itself automatically. You can choose 2, 5, 15, or 30 seconds, depending on how live you need the monitoring to be. The refresh and stop refresh buttons let you update the data manually right away, or stop automatic updates respectively. The worker pool queue section shows the overall picture. Pending tasks and pending timers indicate how many tasks and scheduled events are waiting to be processed right now, while total tasks and total timers show the cumulative number processed since the system started. If the number of pending tasks keeps growing instead of staying near zero, that's a sign the system isn't keeping up with demand. The worker queues table breaks this down per worker. The worker number column identifies each individual worker, and pending tasks shows how many tasks are waiting specifically for that worker. This makes it possible to see whether the load is spread evenly across all workers or stuck on just one of them. Let's talk about threads, a concept one level deeper than workers. If a worker is who performs the work, a thread is what that work is technically made of inside the program. Every action the server carries out happens within one of these threads, and threads are what directly load the computer's processor. In simple terms, workers are who does the work. Threads are how that work physically happens at the processor level. The thread stats page is needed when you need to understand not just is there a delay, but specifically why is the processor under load and which part of the program is responsible. It allows you to see overall processor load as a percentage, check how many threads are active right now and what the peak number of active threads has been overall, and most importantly, identify the specific thread consuming the most resources. The settings here are simpler. Refresh period ES again controls the update frequency, 2, 5, 15, or 30 seconds, and the refresh and stop refresh buttons work the same way as on the previous page. The summary row shows the total thread count, CPU load, overall processor load, active threads, how many threads are currently active, and peak threads, the highest number of simultaneously active threads ever recorded. Below that is the threads table, listing every thread. ID and name identify each thread. The name often reveals which specific task it's handling. Status shows its current state, such as waiting or running. And core CPU load and total CPU load show how much processor time that specific thread consumes relative to a single processor core and relative to the system as a whole. These last two columns are exactly what let you track down the culprit when the processor is overloaded. The last concept is the Java Virtual Machine, or JVM. The program the platform runs on is written in Java, and Java code doesn't run directly on the computer. It first runs inside a special intermediate environment called the Java Virtual Machine. Think of it as a container program that the entire platform lives and runs inside, and which manages things like how much memory to allocate and when to free it. The virtual machine stats page serves two purposes. First, to quickly check the technical details of the environment the platform is running in, useful when diagnosing an issue or contacting technical support. And second, And more importantly, to understand what memory inside the program is actually being spent on. If the platform gradually starts consuming more and more memory over time, this page is what helps identify exactly which objects in the program are piling up and taking up space. Only one setting is available here, refresh period, with options of 5, 15, or 30 seconds, along with the same refresh and stop refresh buttons for updating the data. The first table describes the environment itself. Machine name is the specific Java virtual machine implementation in use. For example, OpenJDK 64-bit server VM. Operating system and architecture describe the server's operating system and processor architecture. Java version confirms the exact Java version being used. This information is rarely needed day to day, but it's useful when a technical issue comes up and support needs to know exactly what environment it happened in. The second table, allocated classes, shows what the program's memory is actually made up of. Class name is the type of object, for example, text strings or internal data structures. Instances is how many of those objects currently exist in memory, and total bytes is how much space they take up together. If one type of object keeps growing over time without an obvious reason and never shrinks back down, that's an early sign of a memory leak. And this table is what makes it possible to catch that early. Together, these 3 pages form a single diagnostic chain. Worker pool stats shows whether the system is keeping up with tasks. Threads stats explains why the processor is under load, and virtual machine stats reveals what's happening with memory underneath it all. Together, they let you trace a path from a general symptom, like the system feels slow, all the way down to its precise technical cause.